All right, folks, we got another kind of gas law here. This is going to be the ideal gas law, and this is exactly that. When conditions are ideal, gases are supposed to behave a certain way. Do they always behave that way? Not necessarily, okay? But nonetheless, we can take a look at what happens when they should, okay? Now, first off, we have some variables that we need to focus on. Now, actually, let's go back for a second. In the combined gas law, remember how we had P1 V1 over T1 equals P2 V2 over T2? Well, that means that we started off with an original situation and we ended with a final situation. The ideal gas law is not that. Okay, the ideal gas law is you have a pressure, a volume, a number of moles, an R value, and a T value. Okay, all of those things are going to correspond, and you're going to have one unknown. Okay, when you have that one unknown, you can solve for that one unknown. Okay, now your pressure can be anything, it has to match your R value. We're going to talk about what that means in a second. Your volume must be in liters. Okay, this is new. Used to we could do volume in whatever. Our volume must be in liters. Our value for N is going to refer to the number of moles. The R value, all it has to do is match your pressure, and then temperature, as usual, must be in Kelvin. Okay, now the R values are what makes the ideal gas law work. Okay, so if you have a pressure in atmospheres, it's really important to look at the units, okay? If you have a pressure in atmospheres, notice how you've got atmospheres right here in the unit of the R value. If your pressure is in atmospheres, you're going to use 0.0821 for your R value. That's going to be R in your PV equals nRT equation, okay? If your pressure is in torr, then you're going to use 62.4. And if your pressure is in kPa, you're going to use 8.314. Okay. Now, if your pressure is not in atmospheres, torrs, or kPa, you need to convert it to one of those so that you have an R value to use. Now, also, we remember from previous units that N, our number of moles, equals mass over molar mass. Okay, so occasionally you're going to see this expanded. You're going to see PV equals nRT expanded to PV equals mass over molar mass times RT. Okay, now let's think about this. Most of the time when we see a cat, okay, most of the time cats don't do this right here. Okay, most of the time when you have a cat, they are going to go to the bathroom outside and they're not going to flush the toilet like this cat does. Okay, you're probably saying, Mr. Coder, what in the world are you talking about right now? Okay, but I promise I am getting there. Okay, this cat will flush the toilet because, well, he's a cat who flushes the toilet. Most cats, when they go pee, they will put dirt over their pee. You see what I did there? Okay, so what do cats say? Meow, meow. Yep. So meow, meow equals dirt over pee is how you can remember the other situation for the ideal gas law, okay? The molar mass equals the density times the R value times the temperature in Kelvin over the pressure, okay? Meow, meow equals dirt over P. That's how you can remember the other part of the ideal gas law, okay? Now, I don't know how many of these problems we're going to get through because we've got to do 4 problems, but we're going to do how many ever we can right now, and then we'll do the rest of them in another video. So this says how many moles of oxygen must be put in a 500 milliliter flask at 20 degrees Celsius to have a pressure in the flask of 1.77 atmospheres. So I know that I'm looking for a P, a V, an N, an R, and a T. Okay? Excuse me. Let's see what I have. Pressure, okay, is 1.77 atmospheres. Volume, 500 milliliters. Okay, we got to be careful with that. I'll explain why in a second. Number of moles is what we're looking for. Our R value, our pressure is in atmospheres, okay? So I'm going to come back up here and I see if I've got a pressure in atmospheres, I need the R value to be 0.0821. Okay, so that's what we're going to put in for R is 0.0821. And lastly, my temperature is 20 degrees Celsius. Now, my temperature, of course, that's a problem, okay? I need my temperature to be in Kelvin. so that needs to be 293 Kelvin. R value matches the pressure, so that's fine. But my volume, what's my volume have to be? It's got to be in liters. So I know that I'm going to do 500 milliliters. Okay, do a little T-chart action here. Milliliters to liters, 1 in front of the prefix, 1 times 10 to the negative 3. And I do that math, and I see that I have 0.500 liters. So now I know my formula is PV equals nRT. So now all I've got to do is plug in my values and solve. Okay, pressure is 1.77. Volume is 0.500. N is what I'm looking for. R is 0.0821. And T is 293. So if I want to get N by itself, I'm just going to divide both sides by 0.0821 times 293. And solve. So I've got 1.77 times 0.5, enter, divided by everything on the bottom has got to be in parentheses. So open parentheses, 0.0821 times 293, close parentheses, enter, and I get that I have an N value. N equals 0.03. Let's see here. How many sig figs do I need? 3, 3, 3. So I need 3 sig figs. So I have 0.0368 moles. Okay, we use the ideal gas law to solve that problem. Okay, does that make sense? Say yes. All right. So again, another one. We'll make this one the last one of this video, and then we'll do one more video after this. Okay, so I know that I need a P, a V, an N, an R, and a T. Okay, now I can already see that I've got grams here. So this is going to be my expanded version of PV equals nRT. Let me write the equation here. It's going to be PV equals, remember, N is the same thing as mass over molar mass. Okay, so I'm going to have mass over molar mass times RT. So that means I need a P. I need a V. I need a mass. I need a molar mass. I need an R. And I need a T. Okay? My temperature is 10 degrees Celsius. We're going to convert that to 283 Kelvin. My volume, 500 milliliters, which of course we're going to change to 0.5 liters. My mass is 1.17 grams. Let's see here. I'm looking for the pressure, so this is my question mark. It says that I'm looking for the pressure in torrs, so I go back up to my R value. The one that goes with torr is 62.4, so I'm going to put 62.4 in as my R value. And my molar mass, it tells me I'm dealing with helium, so I look on the periodic table and I see that my molar mass is 4.00. Okay, so now everything's good with units and all that stuff. So now all I've got to do is plug and chug. So I've got P times 0.5 equals 1.17 over 4.00 times 62.4 times 283. And now all I've got to do is solve. So I'm going to do 1.17 divided by 4.00, enter, times 62.4 times 283, enter. And I get 5,165 equals P times 0.5. Okay, so I'm going to divide both sides by 0.5. And sorry about that. Divided by 0.5. Okay, and I get a pressure of 10, let's see here, how many sig figs do I need? 4, 3, 3. So I only need 3 sig figs. So to 3 sig figs, this is going to be 10300 torr. Okay, and of course I use the ideal gas law. All right, folks, that's how you do it. Once again, it's just knowing what your givens are, plugging them into a formula, and spitting out an answer. We'll practice more in class.